This session is talk about diagonals in the parallelogram, and it says the diagonals of a parallelogram bisect each other at the point of intersection. What exactly are we talking here? Look at this. If I can see that AC is a diagonal, yes, and DB is another diagonal, and they do cut each other at this point O. Now, what is the whole property? It says that AO, right? AO would be equal to OC. It means the diagonal BD is cutting or bisecting the diagonal AC, cutting AC exactly at this point, which is the midpoint of AC. Alright, so that's what it says. And I can see the other way around also. The diagonal AC is cutting BD exactly here in midpoint. Right? It means it is bisecting BD at this point. So that's what we need to prove. How will I do this? This can also be done very easily with the ASA postulate. So for that, let me take this triangle, the triangle DOC. Let me draw that. So I'm just drawing this triangle. That is DOC, and goes like that. Correct? Yes. So that's the triangle DOC, and let me name it as D, O, and C. Good. So the other triangle is this I'm looking for, that is AOB. Alright, I'm looking for AOB, which would be like that, and which would be like that, and exactly like this. Yeah. And I can see this is part of the diagonal, so I'll just make it as a dotted line. Right? Very simple. So that the triangle here, that is O, A, and B here. Alright. So I can name this guy. I'm just writing them in two different ways. That is 1 and 3. And this 2 and 4. Now look at these two triangles. Are these two triangles congruent? Yes, they are. Look at this, how it is. Can I say the angle 1 is equal to angle 2? Why is that? So you look at this diagram. I can see these two are parallel lines. Yes, they are. And this looks like the transpose. So that makes this angle and this angle to be alternating. Alright, they should be equal then. So I can write from this, angle 2 is equal to angle 1. Why is that? Because they are alternating angles, right? Alternating angles. Alternating angles. Very simple. Now, can you see another set of angles exactly like this? Exactly here. Look at this. This guy's and this guy, that is 3 and 4. Again, these two are parallel lines, and that looks like a transversal. So that makes angle 4 and angle 3 equal. So I can write angle 4 from the first triangle is equal to angle 3 from the second triangle. Again, the reason is alternate angles. Very simple. Now, is there anything in common? Right, look at this. I can say the side DC is equal to the side AB. Why? This is one of the properties of parallelogram, that opposite sides are equal and parallel. So I can take DC to be equal to AB. Very simple. That is DC from here is equal to AB. Now why? What is this guy? Why is this? Because opposite sides of the parallelogram are equal. So we understand this. Very nice. So I have two angles equal, one side equal. So I can write A as A postulate, right? From A as A postulate, something I can say that these two triangles are congruent. Once I say two triangles are congruent, what can I do? I can write the corresponding sides to be equal. It means this side is equal to this side, right? So I can write, therefore, I have OA is equal to OC, and I can write OD is equal to OB. Very simple. That is nothing but these diagonals are intersecting at this point, and definitely they are bisecting each other. That's all about it. All right.